Thank you very much for coming. My name is Bella Peatfield from CSE, part of the Bristol Green Doors team there. And I'm joined today by Mark Tyler, who's the other half of the Bristol Green Doors team, and John Coote, who is our virtual homeowner today. So these Bristol Green Doors events are in a similar vein to the face-to-face weekends that we were planning to be running. So the whole point of this is to be able to understand and hear about the experience of other people and the process that they've been through to upgrade their homes and make them more energy efficient. So I'll run through a little bit about the setup for the session, and then we're going to jump straight into hear about John's story about updating his home. First of all, just wanted to say that the reason that we are able to run these Bristol Green Doors events is through Future Proof, which is our project, funded project at CSE, supporting homeowners and builders to undertake energy saving retrofit work on your homes. So for people who are inspired to take action in a similar way to John, and if you're looking to undertake energy saving work on your home, we encourage you after today to get in touch with the Future Proof team because we'll be able to provide free, impartial and independent support to help you make the right decisions for your home and your budget. So we're going to post the details of how to get in touch with Future Proof in the chat box, and we'll post reminders throughout the session. So just to talk you through about how the session will work, I've muted everyone for the moment, but there will be opportunity. We're going to run through various sections of John's story, and after each section there'll be an opportunity for a question and answer session. So we'll be monitoring the chat box, and also I'll explain how to do it, but if you raise your hand, we'll be coming round, and my colleague Mark will be fielding questions from raised hands and chat boxes, and you'll be able to unmute yourself and ask your question to find out more about John's experience. So to do that, to raise your hand, you just need to click on the participant button at the bottom or at the top of your screen, and that will open the sidebar there, and you can just click on the raise hand button, and we'll be, as I said, fielding your questions as we go.
I don't know what I'm doing.
And likewise, if you don't want to unmute yourself, you can just pop your question into the chat box, and we will be fielding questions from the chat box and putting those questions to John as we go as well. So yeah, that's just how that works. So I'd like to introduce you to John. He is a relatively new home opener to Bristol Green Doors. He opened last year and had a very popular, I'd say one of the more popular homes, got a lot of people through the door because he's just done so many different things I think people are really interested to see. So we're really glad that we can try and help communicate some of that virtually today. So hi, John. Thanks for joining us. If you want to say hi, just so people can see you. Okay, well, what I'll do, I will start by playing John's introductory video, just explaining a little bit more about his home and introducing the story of the work that they've undertaken. So let's kick off with that.
Hi, I'm John, and going to tell you about my Grand Designs house. It wasn't like this 7 years ago. It was more like my neighbours up the street there. So we moved in about 42 years ago, raised a young family of 4 girls, and for the first 35 years it was a matter of make, do and mend, whilst dreaming of what we could do with the property, but not having the time or the money to do much about it, and also couldn't conceive of a way of gradually building up towards the ideal home without having to undo some of the progress on the way. So I was fortunate. I didn't win the lottery, but I retired early and but carried on working on contracts and started building up a battle fund. So that 7 years ago, concluded that in my retirement I could afford, if I did a lot of work, do all the things that I'd imagined we could do to this house.
Brilliant. So that's just a little introduction to John's house. So over the last 7 years, John has basically completely transformed this end of terrace, installing solar PV and hot water arrays. You've now got battery storage as well, and you've insulated all throughout the home basically. You've got a very interesting heat store setup that you're going to tell us a little bit about, fed by your wood burner and your air source heat pump. You've got your rainwater harvesting tank that you're going to tell us about. So there's a lot of measures to get through today. So I guess, John, it would be great to just hear a little bit more before we get off, before we get started, about kind of your motivations at the beginning of this process. What was it that made you want to go from the house on the left there to where we are on the right?
Okay, well, I hope you can hear me now.
Yep, can hear you perfectly, thanks.
Okay, I'm not sure, I can't see myself on the screen, but I presume some people can. So the problem with the house was the extensions, the existing extensions, which were built a long time ago, were very poor and needed replacing. They were falling apart, or at least they appeared to be falling apart. When I actually tried to demolish it, it was a different story. So the whole thing needed a lot of maintenance, and we could do better with the land around the structure. So typically, I would sit on the roof mending the tiles and look around and think, this is a wonderful view, but nobody else can see it. I'd like to build some rooms in the attic. We'd like to replace the kitchen with a much better kitchen. We'd like to replace the extension, which was a garage. It's solid brick. It's cracking, leaking. It's awful. So, and my wife had seen too many grand designs programs as well. So we had lots of ideas, and I wanted to do something in my semi-retirement. I'm still not fully retired. I still get a few jobs. I wanted to be active, productive, do something stimulating. And I really wanted a good excuse to buy some cool tools. So the objective was to create a comfortable house to grow old in, but to do as much as I could myself to keep the costs down. My architect, who was an early green doors man, motivated and helped me to achieve what I've done. I've got to give him a lot of credit. But you don't need to be lucky and find somebody like him. You can use the future-proof team nowadays. To keep the cost down, I'll just point out that skip on the front drive is full of concrete, hardcore bricks. It's half the price to get rid of that sort of material, which can be recycled, than to just have a rubbish skip. So if you've got soil you can keep separate, or bricks, then it cuts half the cost. So I think that's about it in terms of motivations. Any questions?
That's really interesting. Yeah, please feel free to start asking questions as we go. I guess my question was, do you think people who, obviously you have quite an engineering background, but do you think, you know, if you don't necessarily have an engineering, a job in that industry, that a lot of the things that you've done is still possible, or do you think if you'd started off with a different perspective that you might not have installed some of the measures that you've gone on to install?
I guess so. the heat store is the most technical component. I was fortunate when I was researching online to find a company in Swansea, and I spoke to the owner, and he was a very interesting chap. We spoke for hours. He was trying to give his knowledge away all the time. So a lot of the things I've done come from his ideas, not my ideas. Excuse me a moment, I've got to get rid of this phone call.
The phone ringing there. I thought it was all going too smoothly, technically wise. Right.
So it's not my ideas, it's just me reading up on these things, going to shows and learning from the people there. And everybody can do that. Maybe they don't want to do it themselves, but I think they can imagine a bit clearer what is possible if they go and talk to some of these experts. Don't listen to one person. Don't listen to the salesman. Listen to the engineers.
You would say that. And what were the shows that you found particularly useful going to?
There's a magazine called House Renovations and House Building, and they run lots of shows at the big show places like Shepton Mallet, Birmingham. Well worth going to see.
Okay.
You can see 3 or 4 vendors at the same place and get lots of different ideas.
Okay, great, thank you. Have we had any questions come in, Mark, or should we move on to talk about more specific measures?
Yeah, we've had a question through from Tricia, just asking if the architect helped with the overall design as well as the green design.
Yes. We had a lot of discussion about the design. I came up with my own ideas to start with, and he had to move me away from quite a few of those.
Why was that? Why was he moving you away from your initial ideas? What was the reasoning?
I think he knows what's possible. My ideas were a bit more idealistic, I think. And he did insert a good few ideas, but a lot of my knowledge about the insulation, etc., came through him. And certainly the implementation, he gave me such detailed drawings, I could do it all myself.
Yeah, because that's another thing to point out, isn't it? That a lot of this work you did yourself, didn't you?
Yes.
Yeah.
I did use bricklayers and carpenters to help me because my wife insisted she wanted it completed before we died. I could do it all, but it would have taken me. I'm still working on it now.
It's your project, isn't it?
It's my life project, yeah. Until I run out of energy.
Okay, great. Thank you. Any more questions, or shall we go on to talk about insulation and glazing?
There was a general question from Vaughan as to whether or not the slides and recording are going to be available after we've done the event, and the answer to that is yes, they will be for, I believe it's 30 days, is that right, Ella?
Yes, it's for 30 days. I'm afraid I should have mentioned that at the beginning. Yes, we are recording this. So please don't turn your video on if you don't want to be in the recording, or you can email us after and we'll remove you. But yes, this will be available, and we'll send around the link afterwards to the recording to everyone that was registered.
And then there's a couple more. One general question from Andrea asking about heat store, heat source, air source heat pump, difficulties around that. Obviously, we're going to come on to that in a bit. And then a question from Mick Dunk. Asking if you knew all about the green measures you would install at the beginning, or did it evolve? So did you have all these green measures in mind, or did you start adding to them bit by bit by bit?
I had the idea that I wanted a really comfortable house at the end, but I learned all the way through, yeah. And certainly the there are a number of different alternatives in the way you can implement this. So I did learn as I went on which one was the best for us.
Okay, thanks. Lucy, you've got your hand up. Lucy Craig.
Yes, I just wondered, I was doing a chat as well, I'm sorry. As a matter of interest, why did you make the 2 windows at the front of the house to the left of the front door only partial windows?
That is a staircase.
Ah,
So
right.
I didn't think the wife wanted people looking in at her legs as she walked up the stairs. I do have 2 panels which I'm going to put on those areas, which are windows. They're painted onto a sheet of plastic, but that's a project for the future. Someone.
More aesthetics.
Yes.
Question from Jerome, I think, who's asking if you needed qualifications to do the work that you've done yourself, so plumbing or electrical qualifications.
The plumbing, you don't need qualifications. I did get myself an MVQ3 training book so that I knew what all the rules were. The electrical one, the building inspector will sign it off at the end. So I can do it all, but an inspector has to sign it off. The wood burner, I put that in myself, the chimney in myself. When I spoke to the supplier, he was very happy with my understanding of what all the rules were for installing that, and the building inspector passed it with no problem.
Great,
thanks John. There is one more question, but I don't know how we're doing on time, Bella.
We could go for one more question and then we'll go on to talk about the measures specifically.
Okay, so first of all, John's saying thanks and well done. So Lucy's, okay, sorry, that's the same question from Lucy. And then just a interjection from Future Proof. Electrical works are included within Part P of the building regulations and therefore do require a minimum competence to proceed. So there's a bit of legislative information for you.
Yeah, and that's something that we can help with Future Proof, is all of these kind of bits of information.
Yeah, I didn't put the solar panels on. 600 volts is a bit too dangerous for me.
That seems completely fair. Okay, great. Well, let's move on to talk about the insulation and glazing that you put in, John. I'm going to play the video that you pre-recorded, and then we'll go on to take some more questions.
So, in summary, about 7 years when I started working on the upgrade project, we demolished the side extension and the rear extension, which were both very poor quality, with a view to building up a much bigger footprint on the site. We put in the foundations and then got the bricklayers in. They started by putting a layer of insulation brick, special insulation brick, to stop the heat going down into the soil. And this was at the same level as the Celotex, which goes under the concrete flooring. We then built up a shell and had external insulation applied all the way around. We removed all the windows and installed triple glazing for all the vertical windows, and for the roof lights we put double glazing in. Most of the windows we viewed as a potential heat gain as well as heat loss, so we installed some with blinds which were internally mounted. This keeps them clean, basically. and that's worked out really well, especially for the bifold doors, which I'll show you now. This is looking out into the garden through the bifold doors with the blinds half closed. In the summer, this stops the vast majority of the heat coming into this room, which is absolutely essential.
Great. So that was a little bit of background about the glazing that you've installed and the insulation, John. I particularly really like the bottom right image that you've got there, which is one of what you were talking about there about the passive solar gain, where you introduced that kind of roof light, and it's also just a really unique kind of architectural piece as well. Did you want to talk us a little bit more? And you've done a lot of insulation, and you didn't necessarily go into too much detail in the video, but I suppose what kind of was your process with the insulation? Where did you start? Was it when you extended, or what part of the house did you go to as you worked round?
Well, I mentioned the under the bricks on the new part of the property. Of course, you can't do that on the old part. So we had to suffer from any heat going down into the ground there. We put in all the insulation on the new structure. Then we started putting insulation in the roof between all the joists. That's quite a challenge. It takes a long time. And if you want it reasonably airtight as well, you've got to be very precise. Having put the concrete floor down on the new part, we then looked at the old part of the structure where we got a wooden floor. My intention was to replace that with a concrete floor to the same design, and that really was essential, because the wood floor requires ventilation, and with the ventilation going through, the draft is really bad. So that was the last part we did when we insulated the floor in the old part of the house.
Great, thank you.
We did have an infrared survey done beginning of last year, where we could see how well we were achieving things. I knew there were some bits of work still to be done. You can see this on the top right hand side, this brick wall next to the bay window. There's a cavity behind that, and that cavity goes straight through to next door. So all the air from her air bricks goes through into that space as well. So the insulation on the outside is not solving all the problems for me there. I have now insulated on the inside there as well. I didn't put cavity wall insulation in because initially, well, it's only a very small patch, but initially I was worried about for the whole house. The wall ties were all rusting, so putting cavity wall insulation is possibly going to make that worse.
Great, thank you. That's really interesting. Did we have some questions come in?
Yeah, we certainly did. Just staying on the topic of insulation, at the front of the house, I think you may have answered this already, but did you insulate the front externally or internally?
Externally. If you look at that picture, you can see the blocks of insulation. That's what's put on the outside, and it's at the same location as the wood on the window frame there. So it stops any heat going across the break there.
Okay. And that infrared survey you mentioned, was that a cheese survey?
That was the cheese survey, yeah.
It was, okay.
Well, one of the things they found in that, which I hadn't really thought about, was on the external walls, you need to put plaster to stop the air coming through the bricks. And what he commented about whilst we were going around was, he says, if you put electric sockets on the wall, you need to plaster behind them. And sure enough, when we went to an area where I dug out and put a socket there, it was definitely cold.
So a useful survey to have then, which is...
Yes.
A couple more insulation related questions. So how did you insulate the floor in the older part of the house?
Right, I took up the wood floor and all the joists and the bricks supporting them, and fortunately there was a thin concrete base underneath which was exactly the right height for me to lay some 10 centimeter Celotex on and then pour the concrete, having put down all the underfloor heating pipes. So my underfloor heating is water embedded in about 8 inches of concrete.
Great. Any more questions, Mark, or should we move on?
Well, there's actually quite a few now. If the insulation was external, this is from Hugh, how did you negotiate the step with the neighbouring property and the eaves and any detailing?
Okay. The step to next door is just finished with the external coating, the white normal external coating for houses. With the guttering, it actually goes up behind the guttering and onto the roof. It joins up with the roof. That's an essential detail that my architect coached me in, because I do understand that if you don't do them at the same time, builders will not worry that there's a big air gap at the top and all the heat's getting lost out through that gap.
And one on the windows, where are we? They're all coming through now. The roof windows, were they only double glazed?
Yes.
And what was the reason behind that?
Partly weight and cost.
Weight and cost, okay.
Yeah, we had to haul those windows up onto the roof ourselves, and they're steel windows. If I put triple glazing in as well.
I actually had a question myself about the blinds. You said they're crucial.
Yes.
So without them, what would happen? You're just talking massive overheating.
Yes, you'd cook.
And were those blinds installed with the windows, or is it
Yes.
something you thought of after the fact?
No, we bought them deliberately with them installed. It's only when we bought them really for a keep them clean purpose. It wasn't until we got them and started using them we discovered how effective they really were at reflecting the heat. Also, they tend to reflect the heat back into the room during the winter. They do tend to keep you warmer.
Okay, we've got a few more questions here, but I don't know how we're doing on time, Bella.
I think let's keep going and we'll keep revisiting the questions as we go, because with each section we obviously can stimulate more questions. So does that sound okay?
What I was thinking was perhaps, I don't know how up for this John would be, but after the session at some point, maybe he'll look through these and maybe we'll upload them somewhere with the answers if we don't manage to get through everyone's.
Yeah, fine. Yeah.
The other thing to point out was, for those that aren't aware, John is on 2 different feeds. So there's a video of John and then there's John's audio. So it is possible to see John if you go into speaker view. Otherwise you'll just see the word John, his name.
Okay, brilliant. So let's just touch on heating and hot water, because there's some interesting points here that John covers.
This is my pride and joy, my heat store tank, which was specially designed for me by heat store tank supplier, and all the kit but I self-assembled this with significant help from my son-in-law. And what you can see on this side are the outputs, which are the underfloor heating pipes, the radiators for the bathrooms, and this is the domestic hot water, which actually enters at the lower point, goes in a coil all the way around and comes out very hot at this point, and so it's mixed to control the temperature through into the house. This is the controller for the solar hot water pumps, and I'll show you in a moment. That enters at the back of the tank. Also, you can see the controllers for the immersion heaters, which use solar energy. At the back of the tank we have the wood burner pump. Above the pump itself you can see a mixer valve which controls the temperature of the water going down to the wood burner at 55 degrees. This improves the operating efficiency of the wood burner enormously. Below you can see the input and output pipes for the solar hot water and the heat pump. That's the solar hot water pump operating at the moment. In passing, this is the measure of the heat pump energy generation. So the water in the tank circulates around all the pipework, the wood burner, the solar hot water, the radiators, the underfloor heating, the heat pump. So the solar hot water and the heat pump feed in at the bottom, raising the temperature from the bottom, whereas the wood burner goes in at the top, pushing very hot water down from the top so that the domestic hot water leaves at the maximum temperature. Here are two of the solar hot water panels mounted on the walls vertically to maximise the winter solar energy. And here's another one pointing in the westerly direction. Here's one pointing in the southwesterly direction for the evening sunshine. It's important to note that the bolts holding them to the wall go through external wall insulation. You need very special long bolts in order to mount them on the walls. Also, the connections, hot water pipe connections, are special. They're stainless steel pipes.
Okay, great. So yeah, I think the one question I saw come through from Mary was where in the house is the heat store? That could be a good place to start, John.
Yes, so that's in the attic. It's mounted on a triple joist because it's so heavy. In fact, I put another double one in because I moved it slightly from where the original drawing was. The concept there, I guess, is that heat rises. You can put them on the ground floor some people put them in their cellars.
Great, thank you. Did anyone else have questions, Mark, that came in previously or during that video?
Not directly related to that section. There was a question earlier from Pamela asking if you've had to move out at any stage. So have you had to move out, or have you sort of worked around it?
No, we did not move out. I'll come back to that point a bit later, but no, my wife is still with me.
And there's another one related to your underfloor heating that links back to what you were talking about, the underfloor insulation, I guess. So if your underfloor heating pipes are embedded in 10 inches of concrete, does that make it very slow to respond to the thermostat?
Yes. It's a concept that you create a very large heat store. When I got my first house, I had an electric storage heater which heated overnight and then gave up the heat during the day. And that worked mostly pretty well. There was only once when we ran out of heat. So I'm sort of familiar with having a large heat store. So when my heating engineer recommended this as a way to go, I thought, okay, you do have to sort of plan in advance for when you want to put heat in sometimes. For 3-4 years, I've been running it manually. So you tend to look at what the weather's going to be like next day when you're loading up the heat into the house. But I now have it automated. I'll come back to that when we go on the heat pump story.
Yeah, I had a few questions about how you actually set that up. And I think Tricia is asking about whether you need any other sources of heat during the winter. Again, I think you're gonna come on to that.
Yes. So, as I say, for 4 years I've been running with a wood burner, and you do need to be there to load it up. So if tomorrow we're not going to be at home, we don't need any heat. But having been away for a day and we come back, the heat well, actually it takes 3 or 4 days for it to cool down. But when it does cool down, it takes a day or two to heat up again using this system.
Right, okay. What sort of lifespan do the panels have, the solar panels?
So far, I've not seen any degradation at all. I've been monitoring them yearly, and I get the same output out each year.
How many years is that now?
That's 6 years.
Yeah.
And do you get a guarantee with them as well?
Pass.
Is that?
I'm wondering if that's
10 years, but
on...
Simon, I know the last one had a problem with his controller, not the actual panels.
And I guess on that topic, if you're fitting them yourself...
I didn't fit them myself.
Oh, okay.
But the company's gone out of business. So.
A technical question from Jerome. I'm sorry if I'm not saying that correctly, but he'd like to know, it's not clear to him how domestic drinking hot water is separated from what goes into the radiators.
Ah, right. So if you look at that bottom right diagram, you can see the copper pipe, which has got cold water in it at the bottom. And then when it gets up to the insulation bit, it begins to get warm. So that is totally separate to the water that is in the tank. It actually goes in at the bottom of the tank in a coil, and the coil has got lots of forgotten the word for it. Anyway, the pipe coils round about maybe 50 times as it goes up through the tank. There's a connection about halfway up to draw off some half hot water, which is mixed with the hot water that comes down from the top to get the temperatures right. And if that's still too hot, then it mixes with some cold. But that's totally separate to the water in the tank itself.
Mm. Okay.
So no danger of mixing, and it's at mains pressure.
Okay.
So you don't need any separate valves or anything on your showers or anything else in the house.
Thanks, John. There's a couple of questions related to the heat pump and the wood burner. So Ivana's asking how the heating load is split between the heat pump and the wood burner. Mick Dunk's asking, is it a ground or air source heat pump? I think we're going to come on to that also. in a minute. There's an interesting question here. Why did you favour water solar panels over extra PV? Surely all electric would be lower maintenance as there's no chance of leaks. And that's from John Mildenhall.
Yeah, I appreciate your no leaks comment, because the connectors are tricky. You have to make them manually. So I wouldn't advise people to go for the solar hot water. I wouldn't have put PV on the vertical surfaces. It's free energy, basically. So.
Right, okay. So from here, it's solar thermals, PV, and a wood burner feeding into an exchange tank backed up by an immersion, in summary. Is that right?
And just in the last 6 months, 9 months,
The
heat pump.
Heat pump,
yeah.
okay.
And just to clarify for everyone, it's an air source heat pump, and we're going to come on to that in just a couple of minutes.
Yep.
So John's going to go into a bit more detail. So shall we keep moving a little bit? We'll continue answering questions.
Oh, can I just make a comment about heating of the house? I lived with it as I was building. We lived with the heating going in on the ground floor, and I found that there was no direct heating required on the first and second floors. We could take the radiators out up there, and we were still warm. With the external insulation and the heat rising from a comfortable ground floor, the bedrooms were at just the right temperature. It's something you only learn when you live with these things. Okay.
So, yeah, no, that's a good point. Thank you. And yeah, I'm just going to get us going on the next section, because it's still kind of related to heat and this topic that we're covering.
So, having got some heat into the house through the solar hot water or the wood burner, it's now essential to keep the heat in the house. And here is a mechanically ventilated heat exchanger. So we have air coming in through pipes from the roof, going through a heat exchanger to extract the heat from the air going out, and then through these plenum boxes to either blow the air out through this box or suck the air in from different rooms through this box. So those air pipes snake around the house, delivering or collecting air from different rooms. Here in the kitchen you can see it's collected from above the cooker and delivered at the other end of the room. In the old part of the house, we can't hide the pipes above the ceiling or anywhere, so we have to put conduits along the wall in order to carry the pipes to blow the air in at this end and suck the air out this end, because this room is the TV cinema room right in the middle of the house now. It occurred to me after doing this that I needn't have had the red pipes within those conduits. I could have just left the pipe out and the air would have gone out that end anyway. It's important to note that for mechanically ventilated systems, the house has to be very well sealed, air sealed. And here you can see the special double-sided blue tape here for sealing the membrane behind the plasterboard to the breeze blocks. Breeze blocks are so named because air does go through them. So it does require you to do a very good plastering across these type of walls.
Great. And perhaps you could just introduce a little bit about the air source heat pump as well, John, and then we can kind of talk about all of the questions that have come through and talk about all of those measures kind of in one go. Does that sound okay?
Well, can I just cover 1 or 2 points on that ventilation thing?
Yes.
I can't recommend these systems enough. It's wonderful. Gives us fresh air all through the winter. Normally we live with our windows open in the winter, but now we have this running and it's wonderful. One thing I would consider in the future would be having a switchable hot or cold inlet for the air. Where my inlet is, it's reasonably hot because it's above the solar panels, which get hot, which is good in winter. But in the summer, we don't need any more hot air. In fact, we stop the whole thing and we leave the windows open in the summer. But you may, if you want to keep them running, you need to find some cold air. And my neighbour has just run a pipe underground for his system, so he can switch from one to the other.
It's a good workaround.
Yep. Okay. And air source heating then.
Yeah.
So that was always in my plan, but some years down the road, I've still got 4 years worth of wood out the back without me collecting any more. So I don't need another source of heat at the moment. Opening the house to green doors last year, I had a lot of comments about why haven't I got one. So it prompted me to think about it, and I've brought the plan forward. 1, there are grant opportunities. 2, I need to avoid wood burning during the transition into and out of winter. When you just get to winter, you just want to switch the heating on for a short while. I have to run my wood burner and create the heat. And that wood burner runs hot. It's a very efficient wood burner. I cannot turn it down. I phoned them up and asked them, can I turn it down at all in any way? And they say, no. It's made like this to be ecologically efficient. It doesn't produce smoke or particles or anything. It burns hot efficiently, but it makes the room it's in very hot. I would rather have an alternative source during that period and also at the end of winter. So I thought if I got a heat pump now, I could actually do that. And also sort out some of the other problems. It would avoid building disruptions later on. And right now, my wife is making some comments about me working on some rooms she thought were finished. She's just arrived here. So I was a bit concerned about having to run these pipes through the whole house again later and disrupt things. So I thought, why not do it now? Also, it gives me an opportunity to look at the programmable heating. As was commented earlier from somebody, how do we manage these and manage my heating? How is it thermostatically controlled? Well, I was the thermostat. I was the one saying whether there's any heat needed. But in the future, I want to automate that. And so I've been considering a lot of different options for that. And I've thought, well, the heat source pump could actually relieve me of a lot of problems. After 4 years of manual operation, I know how the heat flows in this house. And I guess most people don't. They just get a heating engineer to install the radiators, they set the thermostats, they turn the gas heater on and leave it. They have no idea where the heat's going, how much it's costing them, and where they could make it more efficient. Having spent 4 years with it manually operated, I now have a much better understanding of where the heat goes and how it distributes in the house. So I was conceiving of some control rules that I can add to my controller that you could see on the tank upstairs. And yes, I can program it, and I could put some sensors in and control it. But using this heat pump, it relieves me of a lot of problems. I can now set this to provide heating for the tank at 35 degrees and set the underfloor heating to very fine limits at certain temperatures, and it will provide the heat whether I put the wood in or not. It will provide the heat. So in the winter now, it will come on when it starts doing more than a little bit of heating. I will think, can I put wood on the fire to replace it now? And when it gets cold enough, I can chuck the wood on the fire in the morning, keep it running all day, and provide all the heat, and this heat pump will never come on. So that's how I'm envisaging using it. If we go out for a weekend, it'll carry on working and keep the house warm. For the next 7 years, I do not have to pay for my heating. The government grant covers the whole cost of heating. I'm not getting any money back for installing it, but I could run my heat pump without cost for the next 7 years. Okay.
That's great. It's really interesting stuff. So I guess we've had a few questions come through. I'm not sure if we've answered Michael's question, which was to just cover that point about how much do you get back from the renewable heat incentive, and that's what you're talking about, isn't it? The government grant that you mentioned there is the renewable heat incentive. Yeah. So I think where he said, how much do you get back? The fact is that you're covering the cost of your heating for the next 7 years now.
Well, with a COP of 3, which it normally runs at about, it covers the cost of the electricity.
Mark, did you want to pick up any of the other questions? I just saw that one pop up as I was.
Yeah, sure. So Hugh had a few questions. I think you may have answered the first one. So what is the ventilation strategy? Were those mechanical heat, ventilation heat recovery inlets? And that would be a yes, wouldn't it, John?
Yes, they're on the roof. They're only about a metre apart. The lower one takes the clean air in, and the upper one near the ridge, it exhausts the hot air, or the cooler air, but smelly air.
I'm quite curious about the neighbour's strategy. So the cold air inlet, how does that work?
Okay, in the summer, I would be drawing air hotter than the room, is the house itself. Because of those solar panels, they get very hot, and the heat comes off of those into my air inlet, just because of where I've sited it. It's something I hadn't considered originally. You can, if you look at some systems of advertised, you can see their systems have a pipe which go underground, circulates underground around, about a metre down or something, whatever you want to dig. It cools the air, and so when it comes back to your house, you've got cooler air than you would normally get. So in the summer, this is ideal. As I say, my neighbour's put a mechanical valve on his, because we discussed all this when I was talking to him about what I found wasn't working too well. So he's done that, and he gets about 10 degrees temperature drop.
Wow, okay. This is something I come across when I'm advising people over the advice line at CSE. So when people are considering whether or not to have a heat pump fitted, something that we tell them that they should always consider is whether or not they're going to be generating enough heat for that property size. So one of the things to consider there is whether you're going to need to resize your radiators, or if you're going to fit underfloor heating. And I understand obviously you've got underfloor heating. Have you resized radiators in the household, or what other forms of heat distribution have you got?
The only radiators I've got are one in each of the bathrooms for basically towel drying, but that's not really needed. This whole house is dry. Anything you put out, we dry our washing in the attic because it's so dry. But heat-wise, the heat rises. I thought, in fact, it gets hotter as you go into the attic. And what I did try to do was to recirculate the hot air from the attic through the mechanical ventilation system effectively by drawing more air out of the attic and trying to circulate it downstairs. But it does even out the temperature. It doesn't really transport heat very well, but it does even it out.
Okay. Does the back boiler have, sorry, does the wood burner have a back boiler?
Yes.
Or is it just, it does, okay.
Yes. Yes, and there's a pump which sends the water around that and back up to the top of my heat store. And as I said earlier, the water is set to 55 degrees going in, and it normally comes out at about 60 to 70 degrees. So I can vary the speed of that pump, but the heat generated is pretty constant. I have to fill it up with wood, and if I leave it for an hour, I may have problems getting the next lot of wood to relight because most of it's burnt away.
Okay. I had another question about the heat pump actually. So obviously you've got a big battery bank. Were you not to have that and you're running the heat pump, would you be considering whether or not to be on a single rate tariff or a dual rate tariff with a cheaper rate at night? What would you suggest would work better if you didn't have PV?
Right, well, I've got a big heat store, so I could run overnight and heat the floors up, and it'd be comfortable for the whole day. No problem. So I could work that way. But because I've got the wood burner, I tend to do that when I'm up during the day.
Right. Did you have the heat pump installed by an MCS accredited installer?
Yes.
Yeah.
The only way you can get to the grants is if you do that, yes. The same with the solar panels.
And was there a particular order in which you installed the technologies? Was there a cost efficient order or a heat saving efficient order? How did you decide?
We'll come on to that slightly when we look at the kilowatts usage later in the presentation. It shows you the order in which I did things. Really, it was as soon as I could get the solar cells on the roof, I got them on the roof. That was with no insulation. In fact, doors were not on the house at the time either, or some parts of the house.
And there was a related question from Mick. Was not having radiators in upstairs bedrooms or rooms compliant with the RHI stipulations, or did you install them and then remove them?
I removed them before. I removed them about 2.5 years ago. It's been 2 years, I think, discovering that we didn't need any heating in the bedrooms. And so when I went through replastering all the walls, because it's an old house, I took this opportunity to strip all the walls and do things like renovation of each of the rooms. And I took all the radiators out, took the floorboards up so I could get all the pipes out.
We've got a question that's come in from Lucy asking, when you say heat store, is that the same as a battery? And if it's a battery, can you tell me what make it is? But we're actually going to move on to talk about your battery storage now. So hopefully that will cover. So we're just going to play the video of John's kind of that he's pre-recorded for us, and then John will go on to answer any questions about the battery storage. That's okay.
So here is one of my indulgences, the Tesla Powerwall. This means that the 6 kilowatt solar cells that I've got feed directly into this, and it stores 13.4 kilowatt hours of electricity and supplies the house with that until it runs out, and then this box here switches me back to the mains. During this winter, I discovered that when we had the storms coming through, it decided that if we had a serious storm, it could cut the electricity off. So it decided to fill itself up overnight with electricity, just in case we lost our electric. If that was the case, it would have kicked in and supplied me with electricity without the mains. I've been the only house in the street with power to charge my mobile phone again. Whoopee. This box monitors the heat flow and the electricity used, and feeds into my app and tells me how much energy I'm actually generating.
So yeah, so I suppose, John, in response to Lucy's question, you have the battery storage, which is the Tesla,
Yep.
and it's the Powerwall too.
Yes.
Yes.
And when I talk about heat store, I'm talking about the hot water tank in the attic, which stores all the solar hot water and wood burner and heat pump hot water. So I've not installed a charging point, which some people might do when I install this, because I'm unlikely to buy a rechargeable electric car. Unlike Simon, our last presenter. Did somebody ask why? Did somebody ask why? I'm sure people are going to ask why. Right. I don't know whether anybody else is aware of the technology, but do you remember Back to the Future, where he puts aluminium cans in the tank to power the car? Aluminium's got a hell of a lot of latent power in it. And about 12, 15 years ago, aluminium batteries were invented. They didn't work very well. There were lots of problems with the process of how it degraded. But in the last couple of years, a Bristol engineer has invented a workable aluminium oxygen battery. And if you believe the publicity, within 3 years, we will be able to drive into Tesco's and change our electric aluminium batteries and drive for another 1,500 miles, which is a lot better than the 150 miles or whatever you get on a rechargeable battery. And in order to take advantage of this, you just drive your old car to the garage, and for 3,500 was the number that was quoted, they will take your engine out and tank out, replace it with electric motors and an aluminium battery, and off you drive again. That's what I'm waiting for.
Great, thanks, John. we've had a few questions in about the cost for the battery storage. Would you be happy to share with us how much it costs?
Well, it's written in the case study literature, which is on the your website.
That's right, yeah. So we can send people to the case study that has got up-to-date costs. So yeah, so if you were interested in looking at Michael's question, the total cost of all green technologies, I'll actually post the link to John's case study in the chat, and you can have a look, and it's got a breakdown of all the costs.
So it's not going to pay for itself. It's a lifestyle choice, and our lifestyle has been up to now with the solar power, which comes in after midday because of the direction it's pointing. We would schedule our use of electricity for when the sun's shining in the afternoon. We're now free of that constraint. So it's a bit of a lifestyle choice, but also we use most of the electricity now. Previously, we were just shoving it back in the grid and not using it. Now, most days, well, we can use a lot of the electricity, but certainly during the winter, we use all the electricity we generate.
Great. I'm going to move us forward a little bit because we're just conscious of time. So we can briefly touch on rainwater harvesting, and then I'd like to save a bit of time at the end for you to be able to run through your stats as well, John.
Right, yes.
Do you think you could run us through the rainwater harvesting very quickly?
Yes, this was the first thing I did. It will never pay for itself. We save about £3 a month, and the motor, the pump inside, costs £300, and it won't last 8 years. So don't think you're going to save any money. I will warn you, I dug this hole myself, phoned up the supplier a week before it was going to be delivered and said, how far can your crane reach? Because it's behind a fence there, it's quite a way. And he said, what crane? It weighs 350 kilograms. We had to push it off a flatbed lorry, mount it over the middle of this, and then try to drop it in to the hole. I had six of us, early men, trying to lift it using some ropes and drop it, and we couldn't lift it. So I sent them off and said, I'll phone you when I've got an idea. And the following day I phoned and said, right, you can come tomorrow and I'll give you those cans of beer and you can watch me do it all on my own. So I rigged up some levers and pulleys and what have you, and put 5 ropes underneath and some scaffolding and managed to drop it in. But yeah, it's a bit of a challenge doing it yourself.
Good heads up, I think, for people. Make sure you've got a lot of strong friends if you're going to go for that.
More strong friends than I had at the time.
Okay, great. And just in general, the outcome in terms of kind of your water usage and stuff.
Oh, right. So, sorry, my final thoughts, did you say?
Yeah, we can. Yeah.
Oh, sorry.
Unless you've got any questions, I think it'd be good to go on to, because we've got 20 minutes left to touch on kind of, you've done a good job here of recording a lot of your your usage and your outgoing. So I think it would be useful to talk through these and make sure there's enough time for questions. So yeah, if you're happy to talk about this.
Yes. Well, you can see my energy usage in the years running up to when we started the project. Yep. And in early spring, the extension had to demolish, had the gas boiler in it, had the hot water tank, all the utility room stuff. So I had to move that out into the house, but I had to disconnect the boiler. So no more heating. I had to disconnect the Aga, so no more cooking on the Aga. That's a very sad day when the Arga went. So the whole summer spent demolishing extension and so on, and the builders didn't arrive until the winter. So we had to spend the next winter without a roof on the house. And I can tell you the most efficient heat storage or heat insulating solution is the thermal underwear. It only costs £50 for a good set of thermal underwear, and it's worth so much more than any other insulation you can find. We already had them from our trips to Machu Picchu up over the mountains there on the Inca Trail, etc. So we're familiar with being out in the cold at night. So we survived that. The first thing that went on the roof when it got built was the solar panels, which you can see giving us some energy, the electric PV line. And then the following year, we installed the solar hot water, the green line, and the wood burner. So the order in which we did it was forced on us. We couldn't do anything else. We spent 3 or 4 years with that system. You can see how much the hot water contributes. Not very much, really. Probably not worth it, I would say. The solar, we didn't use all of that energy. And you can see from the wood burning, the energy usage is confined to about 5 months of the year. Whereas when we're using gas, it was more like 7 months. So my sense was that the insulation of the house has shortened the winter by a couple of months, effectively. And last September, we installed the air source heating and some extra solar panels to go with the store, the Tesla store. We did this because if you buy solar PV at the same time as you buy the Powerwall, the VAT reduces to 5% instead of 15%. So that 10% difference paid for the solar panels, a no-brainer.
That's a great tip. Great
Yep.
money saving tip at the end there. Some comments that people love those graphs. There's a question about...
Lucy wanted you to repeat the last bit.
So the air source heating I installed in September last year. So you can see that rising as I just keep running I'm trying to get familiar with its use. So at the beginning I had it running and it used a lot of electricity, and then I discovered how to manage whether I was burning or using the store, so it dropped off. And then I stopped using the wood burner and just left it to the heat store to see how that would work. And so the power usage or the power generation from that increased. And as I say, I'd figured out by then that it was costing me zero. The solar panel increases the amount of solar energy I'm producing. You can see the blue line at the end increasing. Of course, we did have a very hot, sunny few months at the beginning of the year. But I'm using all that energy now, or the vast majority of it anyway. But I am selling some back to the grid, and you can see that on the other chart down there, the green bit is exported. You can only do that if you haven't got one of the grants from the government. Okay.
Yeah, great. Thank you. Really good graphs. Ben has asked what the average internal temperature is.
Good point.
Mm.
It used to be quite sensible, but for a number of years now, we've been going on holidays in the winter to tropical places, and the wife's getting rather used to the warmer temperatures. So you can probably see an increase in the energy usage over recent years, and that is related to the thermostat settings, which are tending to go up. We are getting older, so I forgive her.
I've been keeping a note of all the questions that have been asked, and I think I've got the ones that haven't yet been asked. So just going back to what you were talking about earlier with the Tesla battery wall, you mentioned that if there was a power cut, you would remain on supply, and Jules wondered if that was actually allowed. Are you allowed to run your house in islanded mode during a power cut? Jules thought there were regulations against that in case people doing maintenance on the network weren't aware that bits of the circuit were live.
No, it isolates itself from the network. You have to rewire your house through it so that you can do this. That box on the bottom left in the picture actually takes the mains in. Yeah, you get back. Yeah, the bottom left there next to the Tesla. That box takes the mains in and will isolate it when I go on standalone mode.
Okay.
Just a point. In the time I've had it, we've had 7 power cuts. One of them lasted for a minute, to a couple for half a minute, and some only for a few seconds. But the device will monitor that and tell me.
And you said that it thought that because there was going to be a storm, it charged it. You might get disconnected, yeah. And as a result, it charged itself up. So
that's an option on the app.
Right. Okay. Does that mean that it's not fully charged at other times? Is it only partially charged, or?
In this case, it was in the winter and it was only partially charged. I've got it set to keep 10% in reserve. So if it gets down to 10%, it'll switch me to the mains. If the mains disappears, I will have 10%, so that's 1.3 kilowatt hours ish, to survive for a short while. So you don't want any power hungry devices connected up at that point.
We could do a quick fire round of questions.
Yeah, let's do this.
Okay, so just working backwards. So to rainwater harvesting, Tricia was asking about what you actually use the water for. Was it loos, washing? Vaughan contributed that possibly, yeah, the toilets, washing machine, possibly the garden, washing the car. Anything else?
We don't use it for the washing machine. I think I would need to put a filter on it. We do get a few bits of leaf and such like come up through it on occasions. But we use it for all the other things. We bought it specifically for the toilets. You'll have to plumb everything separately then, of course.
Right.
And it's a gravity feed system, so you've got to have pipes which go downhill all the way from the tank.
Hugh, I think you asked this a couple of times. Why wouldn't you recommend solar thermals? As he understands, their efficiency is 70 to 80% compared to 10 to 20% for PV.
Yeah, it's a maintenance, it's a leak issue maybe, servicing the valves and the pumps. I'm not sure it's really worth it for the amount of energy I'm getting out of it. If I had them on sloping surfaces, and I couldn't do that because I got PV, I had no more room left. It might be more efficient, it might be better, but I took the other option of going for vertical walls.
There's a good question here from Kirsty, as we are coming to the end, but what were the biggest lessons that you learned through the journey, or perhaps the biggest mistakes that the people watching will want to avoid?
So I've got the next slide for that, haven't I? Or is there another slide? I can't remember.
No, sorry.
Final thoughts slide I got here. Yeah, that one. Yeah, yeah. That's just to prompt me to read off these. I didn't do wind or underground or cavity wall. I've covered that. I did a lot of research. I got a good architect. I was lucky there. I would comment that most builders think if it looks right, it's okay. They don't understand the importance of details. If you don't go with somebody who's thoroughly certified for doing this type of work, then get a measurable thermal deliverable from them. Tell them you need this achieved and get it in writing in terms of a measurable, like the thermal survey type thing, before you start. I've covered the switchable air vents. Oh, reversible heat pumps. I'm a little bit disappointed that I didn't think about this early. The heat pump can be put in reverse and produce cold, but my system can't make any use of that. I would advise some people in the future to think seriously about a system for using that, because it seems to me summers are getting hotter. Certainly, my next project is going to be an air conditioning system which uses the excess summer electricity I have, so that I can cool myself down. And flared roof lights. I don't know whether you can see on that roof light, but the edges are flared outwards. It lets in more light and it looks better. And I came up with that idea once I started. That's it.
That's great. Is that all the questions, Mark? I think.
There are still a few more. I don't know if you wanted to say a bit more about future-proof.
I was gonna, yeah, if we can I've written in the chat box, but for those people who still have questions, want to find out more, do contact us at Future-Proof. I've put, I'm actually just going to skip ahead. I've put our website address in the chat box there. We'll follow up with an email with all of the details, but our team will be able to give you free and independent advice to talk through what it is that you're looking to achieve on your home, and help answer these questions about ideas about the sequencing of the measures that you might want to install, how to maximize your budget and maximize the energy savings that you might want to achieve, and just what will suit your home with a whole building first approach. So we would say, yeah, contact us. You can call, email, or visit our website to request contact with one of our advisors, and we'll be able to talk you through. And John has talked about the importance of having good builders, and we work directly with a network of highly skilled builders who know how to install these types of measures, and that we work with to make sure that they can do this kind of high quality work that we're looking for. So we can help connect you with those builders as well. So definitely worth getting in touch if you're interested. So yes, thank you very much for that. And that's kind of my bit done. And then any more questions that we can sneak in the last 4 minutes, let's do it.
And fill in the survey, please.
Yes, please fill in the survey to let us know how to improve these events. Yeah.
It does only take 5 minutes, and it's really useful because this is our second attempt. So we're hopefully improving. There's been quite a lot of thanks being given by people that are having to leave a bit early. So yeah, a question, does your heat exchanger connected ventilation pipes need filters or need cleaning out?
Yes,
and this person, I think, might have has a cat. So that's a concern.
I would think you wouldn't have a problem. It does need cleaning. I've done it about once a year at max, and it's very, very little for me.